Give him his paper bag. All right, so I have to be very careful when I have subtraction because when you subtract everything in the parentheses that follow. So what I'm really doing is I'm subtracting all of these. So sometimes it's easier if you do a same change kind of thing, however you want to do it. I think about it as distributing a -1 through. You can think about distributing the negative sign through whatever you want. But this will become 6i minus 14 plus I. These signs stay the same because here I'm adding. So plus 5 minus 3i. Now all I have to do is gather my like terms together. So all the numbers without an I on them, negative 14 and 5, give me what? Negative 9. 6i, 1i, and negative 3i gives me 6 plus 1 is 7, and 7 minus 3 is 4.
Wait. So before you do, is like add first?
Yes. Yes.
So, but because there's nothing in front of it.
Right. So this is a 1. Yes.
Hey, that's what I got.
Wait, but
What?
7.
There's something. Oh wait.
Hank, put your phone away. Just kidding, you don't have one. I'm sorry. Kaden, do you have a question? I bet you didn't change all the signs inside the parentheses because positive 14 and positive 5 is 19. So instead of subtracting, you added. Yeah. Doesn't matter. It should technically come second, but that's standard form. This is standard form when you have the real number and then the imaginary number. Which other one did y'all say? I forgot. 7 and 9. Number 7. 7 plus I, 4 minus I. And so I'm going to FOIL or distribute, right? 7 times 4 is 28 minus 7I plus 4I minus I squared. Anytime I see an I squared, drop it, change the sign of the number that it's hooked to. Positive 1, right? All right. Like terms, don't call people stupid. That's not nice.
I didn't call for that.
28 and 1 gives you 29. Negative 7I and positive 4I gives me minus 3I. And radicals. Say again? Yes. I squared always drops off of whatever number. And since there's an implied 1 here. So if you had 3I squared, that would just become negative 3. If you had negative 2I squared, that would just become positive 2. I squared would become negative 1, negative I squared, positive. It just, the I squared drops off and changes the sign of the number that's hooked to it. No. Okay, yeah. The 4 iterations? Yeah. So the 4 iterations, and then I think this will address, let me write those and then I'll go through what it means. All right, so if you ever see I, you really leave I alone. It's the square root of, and I'm not even going to write, I'm just going to write I to the first. We just leave that as I because that's the square root of negative 1 and we leave it alone, right? If we get an I squared, that becomes negative 1. If we get an I to the third, do you remember what that is? Negative I. And if we get an I to the fourth, positive 1, okay? So depending on how you do, when you divide by 4, if you get a remainder of 1, right? Or a remainder of 2, or a remainder of 3, or a remainder of 4. If you're dividing on your calculator, this would be a 0.25, a 0.5, a 0.75, or a 0.0. Yeah. This should be remainder 0, not remainder 4. Yes. 3i cubed, so I'd take the I cubed and go, oh wait, instead of I cubed, I'm going to write negative I times negative I, and since it's a positive times a negative, it's just negative 3i. Does that make sense to everybody? No? Let's say I had 4i to the 15th. Divide it by 4, so 4 goes into 15. No. 4 goes into 15 3 times with how many left over? 0.75 or 3, so I'm here. So I would replace this with negative I, which is negative 4i. Yeah. Negative I to the 15th. So same scenario, everything stays the same except for the I. So the negative stays out here. This becomes negative I, and now 2 negatives make a positive, so it would just be I. Does that make sense? I is not negative. I is the square root of negative 1. Does that make sense? What if it was 3i to the 14th? 14 divided by 4 is what? 4. So it would be remainder of 2, or it goes in there, 14 divided by 4 would give you, 4 goes into 14 3 times, 3.5. Go to the 0.5, it's negative 1, so 3 times negative 1, which is, or you could look at it remainder 2, same scenario. Does that make sense? Yeah. That's correct. So it'd be negative 3, negative 1, which is positive.
How does the I be a negative? I'm a failure.
I squared is negative 1. Or anything with a remainder of 2 when you divide by 4. This is the chart that is the most important to you. I negative 1, negative I 1. And worst case scenario, you can't remember, you can count up from whatever your exponent. So this exponent is 14, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 right here. All right, which other one did you say? 9? What? 20, there's not a 21. 10, yes. 10's good, yes, the biggest. Order of operations, multiplication comes first, yes? Yes. So I'm going to multiply these two together first. So I'm going to FOIL them out. I'm going to distribute. 1 times 9 is 9. 1 times 3i. 7i times 9. and then 7i times 3i. Now, be careful because I'm subtracting all of these, which means I'm doing minus 4 minus 2i. What does this become? Negative 21. Now get everybody together that goes together. Let's see, numbers. 9, negative 21, and negative 4. What does that give you? Negative 21 and negative 4 is negative 25. Negative 20. Thank you. Negative 16. There you go. Right there, y'all were looking at me like I was crazy. Okay, and then 3i, 63i, and negative 2i. There you go. Thank you, Cade. What else? Yay. Give me one. 15, 13, and 15. All right, 13. Tell me what kind of situation I'm in. I'm dividing by what? I, which is what? Imaginary or complex? Imaginary. So remember, there's different rules if I'm dividing by imaginary as compared to complex. So here, since this is imaginary, I am only going to multiply the top and the bottom by I only, and I get 10i over 2i squared. I squared, 2i squared becomes negative 2. So what is 10 divided by negative 2? Negative 5. Oh, it is. Just kidding. Sorry. So it's negative 5. Sorry. Sorry. 15, same scenario. I'm dividing, even though there's a complex in top, I'm only worried about what's in the bottom, and the bottom is an imaginary, so I'm going to do I top and bottom here, I and I, but it's got to distribute up top, so I end up with 28i minus 8i squared over 4i squared. All my I squareds are going to change signs. This is going to be plus 8. This is going to be negative 4. So I end up with 8 plus 28i over negative 4. I could simplify this, but if you simplify it, be very careful because you have to divide every single thing by the same thing. You can't just divide two of them. They're all divisible by what? 4. And since it's a negative 4 in the bottom, I'm going to divide by negative 4 and get negative 2 minus what? There you go. Yes, I divided each of them by 4. Here, here, and on the bottom. Yeah. 6. Yeah. If this directions say to make sure your answer is simplified, you need to make sure you simplify it. If it doesn't, then it would be fine. Yeah. Yeah. 19. Now we get into the situation where we are dividing by a complex and not just an imaginary. How can I tell the difference? Everything we do is in class. All right. What's the difference in dividing by a complex versus an imaginary? How can you tell this is a different situation? That's right. I got a plus or minus in the bottom, right? With a real number. All right. Cade, what's the complex conjugate of the denominator? Conjugate. What do I multiply the top and the bottom by here on this one? Oh, you got all this, girl. Don't be so ugly. When you are adding or subtracting with a number, you have to multiply by the conjugate. You got to change that sign in the middle and multiply. All right, so I'm in a FOIL situation, top and bottom here. 14 minus 7i plus 6i minus 3i squared. At least you didn't cheat. 4 minus 2i plus 2i minus I squared. Change all the I squareds, plus 3, plus 1. 2 i's cancel. And so I get, what's 14 and 3? Negative 7i plus 6i. 4 and 1. Too easy. So if there's a number plus something I or minus something I, so if it's complex in the bottom, see the difference in this bottom and this bottom? Imaginary versus complex. If it's complex, you have to change the sign and multiply. Yes, if you can. Yes, boys.
So like final answer will always be a whole number and I, and then overall whole number.
Sometimes. Over here we got it simplified down to just. Okay. Anything else? Once? That's it. I say things like that, and then I show y'all, and you're like, this is not hard. And then sometimes you do. So, here we go. Couple of background informational. You will have homework tonight because we won't be able to. That went a little longer than anticipated. Do I? Oh yeah. So you'll be able to get your homework done. Thank you, Delaney. I forgot. All right, complete the square. Here we go. I need to go back and review you on a couple things. Remember whenever I told you there was that special pattern, the square dance pattern, the perfect square trinomial, and I said you don't have to know it now, but there will come a time when you have to know it.
Yeah.
Welcome to that time. This is that time. All right, so let's review what a perfect square trinomial is. Tell me what makes a quadratic a perfect square trinomial. Okay, so give me the other two requirements first, because there's 3 requirements. A plus sign, so it's something, something, something. The second sign has to be plus. Perfect squares on the ends. That's exact, not add, but multiply. So the square roots of the ends multiplied and doubled gives you what's in the middle. So the middle of this is going to be 2ab. And if that works, then I end up with a, whatever this first sign is, plus or minus b squared. And so it's an easy factor, okay? Now, why might we want something to look like that? Well, as you just saw in your quiz, many of you went through, it's kind of a good thing that y'all messed it up the way you did, because you see it's hard to solve if you don't use the technique that you are supposed to use. Like if you have something like this, it's a pretty easy solve now, right? It's a 2-step equation, essentially, is what it is. Square root both sides and subtract 1, right? So we're going to force, the goal of this is to force something to be a perfect square trinomial so that we can factor it this way so that it's easy for us to solve. Complex numbers. Bro, I'm going to start trying to put the date on it for y'all. So, okay. Turn it in now, and then put a comment on it that says, turned in under blah, so that I'll go back and look and see that you actually turned it in on time, but in the wrong place. Because I can go back and reference that where you turned it in the wrong place. All right. Tell me this. What would I need to go in the middle in order for that to be a perfect square trinomial? What would go in the blank?
Oh, that's 4x. 4x.
Why, Logan? Explain.
Because you have the square root of x, which is x, and the square root of 11.
But it's got to double.
How do I like compete with that? I'm telling you, my brain don't accept it.
How would it factor?
I tried.
How's it factor? How's it factor? If that's a 22x in the middle, how does it factor? X plus 11 squared. Okay, so we did this, finding this. I don't know if y'all remember, but we did that kind of thing. Okay. What if I switch it up a little bit, though, and I say, I'll pull up their average, and then I'll look at y'all's average and see class average what they were. In order for this to be a perfect square trinomial, what would I need to put?
36. No.
We're so close.
36x.
No.
9.
Why 9, y'all?
What?
It's got to double in the middle, right? It's got to be the product of the ends, the square root of the ends, multiplied and double. You were so excited. I really hated to say no to you, Hank. I really did.
How?
How would it factor now? What's this? We did. We're going to use this to do something else. So you really have to understand it. That's why I'm. What goes in the blank?
7.
Close.
That boy, Noah. Let's go. How do you get 40?
What's the square root of the first
X.
and the square root of the last? Multiply and double.
All right.
Doesn't matter, the first sign can be positive or negative. How does it factor? X minus 7 squared.
I still need a tutor, but.
What goes? Charlie Ray, what goes in the blank?
I know it.
No, you don't.
Yes, I do. 100. I know it. I know it. I know it.
What is it?
45.
Yay!
Oh, boy. Yep.
How does it factor?
5x. Or that.
Yeah.
5. Yeah.
Getting it? One more.
What if the first one
It can be. Bruh.
I know it. I know it.
Wait.
All right, hold on before everybody. Hold on. Give everybody a chance to think about it.
I bet 144.
I said wait.
Yeah, you are him.
Yes.
What you have in mind?
I'm sorry, Madison. I was calling on you.
Wait. So basically,
I was giving everybody a chance.
you divide the x number by 2.
Oh wait, you're on to something. For the C on the end, you basically do what? Tell us what you basically do.
You can divide the x by 2.
Okay, so I'm going to call that, remember it's ax squared plus bx plus c, so I'm going to say it's b. You said I divide it by 2. Okay, agreed. You're exactly right. This is how you find what we call a good C. Boom. Boom. Okay? Now, there's a little stipulation here. Your A has to be 1 for this to work. But we're going to always make sure the A is 1 before we start. So this will always work. Okay?
We got a cheat code now.
We got a cheat code. Half of B squared. Okay? Now, might be kind of hard if B is not an even number, right? So what if I had fraction,
Maybe 6. What? Wait, maybe it's 5 or times 1 or something.
no decimals. I already wrote the answer up there, y'all. Everybody's arguing over what it is. I already wrote it.
Let's just have
You will. Divided by 2 and squared. So just put it over 2 and square the top and bottom. Okay, we'll hope that that comes to us as we practice this a little bit. Okay, here's what we're going to do. When I'm solving to complete the square, and this is the example that's on your paper, so if you don't want to write and want to follow along and have that written, or if it helps you to write, whatever makes you happy. But as I look at this, my first question is this a perfect square trinomial? No. Okay? So, because what is keeping it? Why is it not? What's making it not a perfect square trinomial? What'd y'all say? What else? What about just this side? What makes it not?
Because the 9 is not right.
The 10 is not, no, not the 10, the 9. The 9 is not right. Why is the 9 not right? 9 is a perfect square. It doesn't dance, right? This would be x3. What should I have in the middle for that to work? 6x, and that's not, right? So this is my problem. Do we agree? All right, so what I'm going to do is I'm going to go, you're the problem. I need to get rid of you. But I'm in an equation situation, so how do I get rid of something in an equation situation? You move it. I'm going to call this a bad C. Remember earlier I said this is a good C? So determine if it's good or bad. A bad C means it won't square dance for you. It doesn't work. A good C does, right? It's good to dance. We like to dance. All right, so I'm going to move it over here to this side. And I'm going to say, all right, x squared minus 10x. But here's the problem. When I moved it, I left a hole in my equation. So I'm going to put a blank here just to make it a little bit easier so you see what happens. And I've got negative 9 over here. And what I'm going to do is I'm going to add a hole here too, because I know I'm fixing to put something here. And since it's an equation and I have to stay balanced, I'm going to have to put it on both sides. Okay? Now, what other part? So I subtracted 9 from both sides to balance it, okay? All right, so now the question is what goes in the hole? What goes in the blank? This is right. This is where I use the cheat code, right? Okay. 25. Right? This is my good C. I do 10 divided by 2 and squared. I know I didn't put the negative sign in there, but it really doesn't matter because I'm squaring it. When you square a negative, it becomes positive anyway. So this is 25. It's got to go to both sides of the equation because it is an equation that has to stay balanced. And remember, the whole point in everything in this unit is that we solve for x. We find out what x is. We solve the quadratic. All right. From here, it is downhill. I simply factor and solve. So my equation now looks like this. X squared minus 10x plus 25 equals, what's negative 9 plus 25? Yes or no? Everybody good? Factor the left, what's it look like? X minus 5 squared. How do you solve that? $21. Square root it. That's exactly right. I have one x. I'm going sad math. So I'm going to square root both sides. What is the square root of 16? Close. Right? I got to remember that plus or minus. Remember, that gives me my two answers. And whenever I'm talking about a quadratic that's crossing the x-axis, it's crossing in two places a lot of times. That's why I have two answers. I am going to throw that ball out of the window. I cut Haney's with a scissors last semester. All right. Now I need to add 5. Now I need you to understand what this means because I'm going to need you to split this when this happens. This means that x minus 5 could equal positive 4, or x minus 5 could equal negative 4. There's my two answers, right? So if I add 5 to both sides, I find out that x could equal 9, or x could equal 1. Yes? All right, so that example is written down on this for you step by step. Now, notice little tips at the bottom. The very first thing it says, make sure that a equals 1. If a is not equal to 1, divide everything by a to get rid of it. And let me show you what I'm talking about. If you have something like 2x squared plus 16x minus 10 equals, it doesn't even matter. It could equal 0, it could equal 5, it could equal anything. Let's make it an even number to make it easier. I'm going to divide everything by 2 before I ever start so that there's no leading coefficient. So this will be x squared plus 8x minus 5. And I would proceed. You'd have to leave a fraction in there. I won't start you out that hard to begin with. I'm sorry.
We should go back to the average.
All right, let's do an example. This is number 4 on your work, and I'm showing you this because this one's formatted a little bit differently than the others. I'm just gonna, in the beginning, I'm gonna go ahead and put everything on the same side just so I can get it like I'm used to working with it. Okay, so x squared minus 16x, I'm moving this one over. And I'm gonna, well, I'll go ahead and move everything over just so that it looks the way you're used to seeing it. Now, you have to at least move the x term over, but you don't have to move the c. All right, now, first thing I'm going to do is say, do I have an a in front other than 1? No. If I did, If this was anything other than 1, I would need to divide everybody by that value, okay? But I don't have it, so I'm good. Yes, because you don't, when you complete the square, you have to have 1 here, okay? Yes. Leave them as fractions, though. Yes. Good C or bad C? Why? It's not that you're exactly right. It's not even perfect square. I don't even have to look any further. I don't have to check to see if it dances, anything of the sort, because it's not a perfect square. It's bad. So I'm going to move it. But when I move it, I need to leave some holes, okay? So I have x squared minus 16x. Now there's a hole where I need this c, right? And I've got negative 63. And I'm going to leave a hole on this side because if I add it to the left side, I need to make sure I have a place to add it to the right side. Now, cheat code. What's my good C actually look like? That's exactly right. Both sides. I'm trying to find what x equals. Well, first I have to factor it. How does the left side factor? X minus what? 8 squared equals 1. This is that perfect square trinomial. It's the square root of the first sign, the square root of the last. Yeah. I solve it.
The square root thing.
That's exactly right, the square root thing. What are you calling him? Ched?
So whatever your middle sign is, whatever the
Yes, yes, yes. It would be plus in the middle. So this is x minus 8. What's the square root of 1? Plus or minus 1. I bet you won't. I told you. You'll do it one time, but that'll be the only time. So x minus 8 equals 1, or x minus 8 equals negative 1. Oop. Solve each one. Like if it's not a perfect square, just leave it in the right. So like if I had x minus 8 squared equals 7, I would square root both sides and I'd say x minus 8 equals plus or minus square root of 7. And then I would just add the 8 over there. I can say plus or minus square root of 7 plus 8. Yeah, and just leave it written like that. That's an exact answer and it's acceptable that way. A lot of times we'll do it this way and we'll put the whole number first followed by the radical, but either way is fine. One more from your homework together. Give me an even one to do. 2. Let's do 2 and then let's do 6. How about that? You're going to do the odds tonight. We'll do the evens together. Well, maybe we'll do them all since I'm doing most of the evens with you. We'll just say all, and all you gotta do is copy. You're copying what I do. All right. Do I have a leading coefficient other than 1? No. Solve by I know, but we're still same thing. Is it a perfect square trinomial?
Yes.
Yes. How do you know?
6, 12.
That's right. So I can factor as it sits. That's a good C. This is a happy C. He's good, right? Because he square dances. I don't have to go through and find one that makes it happy because it's already happy. So I can go ahead and factor. The left side factors how? Uh-huh. Minus 6 squared, and the 80 is still over there. Can you solve that? Yes. What do you do? Square root. Kenzie, you're supposed to go to Miss Brennan. She said you're in enrichment. It's working something. All right, now what? What happens here? What happens to this 80? I know I got a plus or minus, but what happens there? How? Bring out a perfect square. What's the biggest perfect square I can divide 80 by? See how none of this stuff goes away? 16 and what? 16 and 5. So actually x minus 6 equals plus or minus 4 times the square root of 5. So now, Bella, this addresses your question. What do I do? Because that's not a perfect square, right? I can't split it up into 2 here. So instead of going, well, x minus 6 equals the positive and x minus 6, since it's not a whole number, I'm just going to add 6 to both sides and say plus or minus 4 root 5 plus 6. And generally, we'll switch that around to look a little bit prettier like that. So perfect squares give me what it simplifies to. Non-perfect squares leave the radical in the answer and go on with it. I don't know. Maybe you don't have to today. I don't know. Give me another one from the. Huh? Are you? Are you selling something during first lunch? For student council? Is he selling with you?
I think I'm selling with her.
All right. Which other one did you say? Might as well just do 4, right? Did we do 4? Is that the one we did? 6. Oh, 6. If you already recognize that that's going to be a bad C if you move it over, you don't have to move it back and forth and back and forth. Doesn't matter. I'm going to go ahead and put it over here and make it equal 0 just because. All right, first things first. Why do you say, oh no? I've got a leading coefficient. I've got to get rid of it. Not only do I have to get rid of it, but that number on the end is not even divisible by 4. I'm going to end up in a fraction situation. Okay, well, nothing to it but to do it. Divide everybody by 4.
Yeah.
What's 35 divided by 4? 35 over 4.
I would put that in the calculator.
But fractions are your friends because it's easier here to work with the fractions than it is with the decimals, I promise. If you can get past looking at a fraction, they're easier to work with in these situations. No. All right. Is 35 over 4 a good C or a bad C?
Bad.
Why? It's bad. We don't like it. It's nasty, right? It's not even a perfect square. It's never going to be a perfect square. So let's move it. I'm going to leave a hole both sides. Well, tell me, Charlie, what do you think I put there? Why? Why is that negative, Ghost Rider? Why is it 9?
Because you divide it by 2.
I am too.
Where's 2 come from?
Where's what?
6x or 6.
I divided everybody by 4 to start with. 24 divided by 4. Now, take out your calculator for just a minute. Let me show you a neat little trick.
Yes, sorry, Joe.
Okay. Take out your calculator and do, and I think I showed y'all this before, but maybe not. Do a parenthesis, negative 35 divided by 4, close the parenthesis, that's my fraction here, and then do plus 9 and hit enter. Get a decimal, right? We don't want a decimal. Hit math, enter, enter. What do you get? Wait, you don't have, it's on the graphing calculator, it does it. I'll show you how to do it on that one, though, but I'll show you. All right, so what happens is on the left, I've got x squared. Oh, how does it factor? Sorry. Well, no, I'll just go ahead and write this. Yes? Now, how does the left side factor? X plus 3 squared equals 1/4. How do you solve that? That's exactly right. Just go ahead and square root it. I've got a fraction. Remember that property? I can split it up that way.
Oh.
So x plus 3 is going to be plus or minus. What's the square root of 1/4? 1/2. See how none of this stuff goes away? I'm sorry. X plus 3 is 1/2, or x plus 3 is negative 1/2, and I hope that you all can solve that from here. Fraction. Has to be fraction. It's got to be exact. Do what? Yes. I'm leaving the odds for you. If you don't get it, we'll work it tomorrow, but try it. The evens kind of mirror the odds, so there's one of each. Yes. To say that one more time. You could, yes, if you recognize that. It won't always work like that to where it did, but yeah, you can do that. All right, I'm still not done with this problem because I have to subtract 3. 1/2 minus 3 is negative 2.5, so negative 5/2. There's one answer. Negative 1/2 minus 3 here. Negative 3.5, which is negative 7/2. 1/2 minus 3 times 2 times 2. All right, I'm gonna set you loose on the rest of them.